Hi everyone. In this video, we're going to be doing A-Level Maths 9709, paper 43, paper form mechanics, May, June 2025. This paper is 1 hour 15 minutes long, so we'll try to finish within that time limit. So without further ado, let's get started. Okay, so for the first question, we're told that two particles, P and Q, of masses 0.1 kg and 0.3 kg respectively, are at rest on a smooth horizontal plane. Then we're told that P is projected directly towards Q with speed 4u meters per second. At the same instant, Q is projected directly towards P with speed u meters per second. After P and Q collide, P moves with speed 2 meters per second and Q moves with speed 4 meters per second. Okay, so for the first part, we have to find the two possible values of U. Okay, so to do this question, let's draw the scenario that they're describing in the question first. So at first, we have particles P and Q, and particle P is projected towards Q with speed 4u meters per second. And then Q is also coming towards P with speed u meters per second. And then when they collide, so this is before collision, and then after the collision, P moves with speed 2 meters per second, and Q moves with speed 4 meters per second. Okay, so we can have two scenarios here. So first scenario is that they can wait. They both move in this direction. So 2 meters per second and 4 meters per second. And the second scenario is that they move in this direction and this direction. So they must be moving in the same direction, right? Like it's not possible for them to come together and reflect back again. It doesn't happen. They always move towards the same direction. So these are the two possible cases that we're going to have to consider. So this is going to be case 1, and this is going to be case 2. Okay, so let's do the calculations for case 1. So we're going to use our principle of conservation of momentum. So we're going to let the direction that P was initially moving at to be positive. So this is going to be 4u 0 times 0.1 minus, because Q is moving in the opposite direction initially, u times 0.3 equals to 2 times 0.1 plus 4 times 0.3. So simplify everything. On the left-hand side, you have 4u minus 0.3u, you'll get 0.1u. That's equal to 0.2 plus 1.2. You'll get 1.4. And hence, u is going to be equal to 14 meters per second. So this is our first possible value. Now let's consider case 2. So again, let's use our momentum formula. So left-hand side is going to be the same. And the right-hand side is where it's going to be different. So since we let the direction of the initial direction of Q to be negative, and both P and Q are moving in that direction in case 2, both of their momentums are going to be negative. So that means that P is going to be minus 0.1 times 2 minus 0.3 times 4. So this is going to be 0.1 U equals to minus 0.2 minus 1.2. So, okay, let me see. Wait. Okay. Oh, wait, sorry. Oh, it is possible that, sorry, okay, so it is possible that they could be moving in opposite directions. So I'm going to let my case 2 be that, okay? So now P is moving in the negative direction and Q is moving in the positive direction. So this is going to be positive. So 0.3 times 4 minus 0.1 times 2. That's equals to 1. And then hence U is equals to 10 meters per second. So this is our final answer for this first part. Let's head on to the next part. Okay, so for this part, we're supposed to find the largest possible loss of kinetic energy in the collision. Okay, so to do this, let's first calculate the initial total kinetic energy. So to calculate kinetic energy, just use half mv squared. So this is going to be half m1 v1 squared plus, sorry, u1 squared plus half m2 u2 squared. So by m1, we mean the mass of P, so 0.1, and then v1 is u1 is the initial speed of P. Oh, okay, sorry. Supposed to be v1 and v2, where v1 and v2 are the final speeds of P and Q. So for v1, that's 2 squared, and then v2 half times 0.3, 4 squared. Hence, this is going to be half times 0.1 times 2 squared plus half times 0.3 times 4 squared. So this is 13 over 5 joules. Okay, so this is the final total kinetic energy. So for us to have the largest possible loss of kinetic energy, our total initial kinetic energy must be as huge as possible. And for that to happen, both the speeds of P and Q, they should also be as large as possible. Okay, so hence we're going to choose the larger value for U, which is 14 meters per second. So substitute that. So for P, that is going to be half times 0.1 times 4U. Yeah, so 4U, that's 14 times U squared plus half times 0.3. Yeah, 0.3 U squared. So U is 14 squared. So type this all into your calculator. You will get 931 over 5 joules. And now we can find the difference between these two to calculate our loss. So this is going to be 180 joules. So this is our final answer for this part as well as the entire question. Let's head on to the next question. Sorry, everyone. I made a minor calculation mistake in here. So this is, I'm sure you would have caught it by now. So I'm here to rectify it. It's supposed to be 183.6 joules. So yeah, so this is our final answer for this part. Let's head on to the next question. Okay, so for this question, we're told that a van of mass 4,500 kg is towing a trailer of mass 350 kg along a straight horizontal road. The van and the trailer are connected by a light rigid tow bar which is parallel to the road. There are resistance forces of X Newton on the van and 120 newtons on the trailer. The driving force produced by the van is 2,500 newtons. The tension in the tow bar is T newtons, and acceleration of the van is 0.4 meters per second square. Okay, so now using all this information, you have to find the value of X and the value of T. Okay, so to do this question, let's draw a diagram for us to visualize all this information they gave here. So I'm gonna represent the van using a box, and this is the tow bar, and then this would be the trailer. Okay. Okay, so the van and the trailer. Okay, so the van is 4,500 kg and trailer is 350 kg. Then the resistance forces on X Newton on the van. So let's say they're moving in this direction. So the resistance force would be here. So this is X newtons. And, oh wait, sorry. X newtons on the van and 120 newtons on the trailer. The driving force produced by the van's engine. Okay, so the force exerted by the van in the direction of motion is 2,500 newtons, and the tension in the tow bar is T newtons. Okay, so to represent the tension in the tow bars, we'll first do it from the van's perspective, like considering only the van. So since the van is pulling in this direction, the tension would be acting in this direction. And even if you don't like put the right direction, if you get a negative answer, that's when you know your initial guess wasn't right. And let's do the same for the other end, close to the trailer. So here, the tension would be acting in the opposite direction. And the reason we do this is to separately consider the trailer and the van as separate bodies so that it would be easier for us to calculate the forces. And if you realize, since these forces have the same magnitude and in the opposite direction, they are actually a action-reaction pair. So the resultant force is actually zero. So there's like no overall effect by these forces, like on the system as a whole. Okay, so now let's start forming equations. So let's take the trailer separately. So the only forces acting on the trailer are the tension and the 120 newtons. So we're going to use Newton's second law, F equals ma. So F is the resultant force acting in the direction of motion, so that is T minus 120. And then that's equals to M, which is 350 times A. So A is 0.4 meters per second square. So 0.4 right here. Okay, so we can straight away just solve for T. So 140 plus 120, this is going to be 260 newtons. So this is a final answer for T. Now let's consider the van separately. Okay, so we're going to use the same method for the van. Let's start using Newton's second law, F equals ma. So the resultant force would be the force acting in the direction of motion first, so 2,500 newtons minus T minus X equals to 4,500 kg times the acceleration 0.4 meters per second squared. Okay, so we found T, so let's substitute the value of T, 260. And now all we have left is X. So let's simplify the right-hand side. You'll get 1,800. So isolating for X, it'll just be 2,500 minus 260 minus 180 newtons. This would be equal to 440 newtons. So this is our final answer for X as well as the entire question. And there is an alternative method to find X without taking into consideration the tension. You can just like consider the whole system as one system. Yeah, and then you just ignore the tension and solve for the other forces. Yeah. So with that, let's head on to the next question. Okay, so for this question, we're given a velocity time graph, as you can see. So it's stated in the question, which models the motion of a particle. The graph consists of 3 straight line segments. The velocity of the particle at time t, seconds after passing a fixed point O, is v meters per second. The particle leaves O with a velocity of 5 meters and accelerates at 0.75 meters squared. So yeah, this is a crucial information for 20 seconds. The particle then decelerates for the next 30 seconds. Yeah, so you can see the velocity is decreasing from 20 seconds to 50 seconds. At t40 seconds, the velocity of the particle is 0. And then at t40, the particle starts to travel back to O, coming to rest at O at time t seconds. Okay. All right, so using all this information for the first part, we're supposed to find the value of t. Okay, so all right, let's try to outline the motion of the particle visually. So at time 0, it starts from O. Okay, then it accelerates and decelerates. And then at t40, it changes direction. And then it comes to rest back at O at time t seconds. So this happened at t40 seconds, and it reached at t equals to t, back to O. And this happened at t equals to 0. So we can say that the distance covered from T0 from to T40 and from T40 to time T is the same. Okay, so so we can equate these two distances together. And to find the distances traveled between these times, we can just find the area under the velocity time graph, because the area under the velocity time graphs gives us the distance traveled in that time interval. So we can just equate these two shaded areas. Okay, so let's find this area first. Okay, so to find this area, we can see it's actually made up of two shapes, a trapezium and a right angle triangle. So let's try to find all the lengths first. So as you can see, we don't know what this length is. So yeah, I'm gonna call it V, all right? Yeah, so to find that, let's look at this piece of information. The particle leaves over the velocity of 5 meters and accelerates at 0.75 meters squared for 20 seconds. So we can use the formula V equals to U plus AT to find V, where U is the initial velocity, so 5, then plus the acceleration 0.75, and time is 20 seconds. So typing this into your calculator, you'll get 20 meters per second. So hence, this we can rewrite as 20. Yeah, now we can start finding the area. Okay, so let's find the area of the trapezium first. So trapezium would be half times the sum of the parallel sides. So 5 plus 20 times the height of the trapezium. So 0 to 20, so 20. And plus the area of this rectangle right here. So the base is 20 and the height is also 20. So half times 20 squared. This is equals to the area in here. So to find this area, we're given the height of the triangle as well as the base length. So the base length is running from T40 to T. So the length we can say is T minus 40. As for the height, we're also not given the V value. So we're gonna let this be W. Okay, let's look for crucial information. Okay, so it just says the particle just decelerates for the next 30 seconds. Okay, so we have to find the deceleration on our own. Okay, let's compute this area first. Yeah, so 450. Okay, so let's find W. So to find that, we first need to know the deceleration. And for the velocity time graph, that is given by the gradient of the curve. So we can calculate the gradient from T20 to T40. So deceleration, it's obviously going to be negative. So it is V minus U over T. So V is the final velocity minus the initial divided by T. So 40 minus 20, that's 20. So this is going to give you minus 1 meters per second squared. And now we can find W, which is equals to U, which is 0 minus 1 times 40 to 50, that is 10 seconds. So would W just be 10 minus 10 meters per second? So the height hence would just be 10. Now let's equate the area of the triangle, half times 10 height times the base, which is t minus 40 equals to 450. Now we're going to make t minus 40 the subject of the equation. So half times 10, that's 5. So 450 divided by 5, that is 90. And t would just be 90 plus 40 equals to 130. Um, Let me see if, okay, don't need any units. Yeah, so this is our final answer for the first part. Let's head on to the second part. Okay, so for this part, we're supposed to find the acceleration of the particle from t equals 50 to t equals t. Okay, so to do that, as I said in the previous part, you just have to find the gradient of the line segment from t50 all the way to t. So this line right here, because it represents acceleration. And since it's positive, we clearly know that the particle is accelerating. So let's find the gradient. So just use the gradient formula, or you can use your v minus u divided by t formula as well. So v is the final velocity. So that's 0 minus negative minus w, which is negative 10, divided by the time. So that's t minus 50, which is 130 minus 50. So this would give you 10 minus 130 minus 50, which is 1/8 meters per second squared. Or you can write in decimal, which will give you 0.125 meters per second squared. So this is our final answer for the second part, as well as the entire question. Let's head on to the next question. Okay, so for this question, we're told that 3 blocks P, Q, and R of masses 25 kg, 20 kg, and mkg, respectively, are held in equilibrium by 3 light inextensible strings OP, OQ, and OR. The strings OP and OR both pass over small fixed smooth pulleys A and B respectively, with P and R hanging vertically below the pulleys. The block Q hangs vertically below O. Okay, the angle between OA and the vertical is 30 degrees, and the angle BOQ is alpha degrees. Okay. Yeah, so all this is given the diagram. All right, so using all this, you have to find the value of M and the value of alpha. Okay, so to do this question, let's first label all the forces acting on them. So let's first label the weight. So for P, that would be W equals mg, so 25g. Q is 20g, and R is mg. Okay, so logically, since they're all connected, they should have the same tension acting, right? Okay, I mean, except for Q. Okay, so let's label this T1, and this as T2. And this as T3, and this is T4, and this is T5. Okay. Okay, so T5 and T4 are the same, so I'll just label this as T4. Same for T1 and T3. Yeah. So these are the equations we have. Now we can calculate them separately. So for T1, we can consider P separately. So since they're in equilibrium, we can say that T1 is equals to 25G, which is equals to 250 newtons. Now let's consider T4. So let's consider R. Okay, so R is T4 equals to mg. Yeah, so let this be equation 1. Okay, now we're going to consider Q. So this is going to be the most complex. Okay, so for Q, there's going to be both vertical and horizontal forces acting. So let's consider the horizontal forces first. So that's going to be T1 sine 30 degrees. Wait. Wait. Sorry, I think T1 should be acting in here, this direction. And then T4. Yep. Okay. Yeah. Yeah, so T1 is T sine 30, and for T4, that would be T4 sine alpha. Yeah? Yeah, T4 sine alpha. Yep. So let's equate those together. T1 sine 30 equals to T4 sine alpha. So T1 is 250, and then sine 30, that is half. And then T4 is mg sine alpha. So 250 times half, that's 125. So mg sine alpha is 125. So this is the second equation. All right. Okay, now I'm going to consider the vertical forces. Okay, so we have T2 as well as T1 cosine 30 and T4 cosine alpha, both acting downwards. Yeah, so T2 is going to be equal to, oh wait, sorry, T4 is acting upwards. Yeah, so T2 plus T4 cosine alpha plus T4 cosine alpha is equals to 20G, which is acting downwards, plus T1 cosine 30. So plus T1 cosine 30. So T2, yeah, okay. So T2, we don't know what it is. Wait, T4 cosine alpha, we also don't know. It was mg cosine alpha. Okay, all right, I think, sorry, so, all right, so for Q, oh my gosh, wait, okay, so for Q, instead of considering like with the particle Q, we'll just, that's a lot of stuff to erase. Okay, so we'll just consider this as its own. So we will get T2 is equals to 20G, which is equals to 200 newtons. Yeah. So now we're going to consider the other forces. So this is going to be our T1, this is going to be our T4, and our T2. So we'll only consider T1, T4, and T2 now. So vertically, T2 is acting upwards, so is T4. Vertical component is T4 cosine alpha. And then for T1, that is T1 cosine 30. So, okay, so T2 plus T4 cosine alpha equals to T1 cosine 30. Cosine 30. Okay, now let's substitute everything. So T2 is 200. T4 is mg cosine alpha. T1 cos 30. T1 is 250 times cosine 30. We get, wait, cosine 30 is this much. So yeah, 125 square root 3. All right. Now let's make mg cosine alpha the subject. So this is going to be 125 square root 3 minus 200. So this is the third equation. All right, now we can divide equation 2 and equation 3. We'll get tangent alpha, which is equals to 125 over 125 square root 3 minus 200. So alpha just be tangent inverse 125 over 125 square root 3 minus 200. That would be equal to 82.5 to 3SF. Okay. All right, now we have to find our m. So to do that, we are going to have to find sine alpha, like an exact value of it. So you can use your calculator for this. Okay. Yeah, so I got rounded off to 5 decimal places, 0.99139. Okay, so M would just be 125 over G sine alpha. So this is 125 divided by 10 times 0.99139. So this would give us 12.6 to 3 SF. So these are final answers for alpha and M for this question. Let's head on to the next question. Okay, so for this question, we're told that a van of mass 2,500 kg traveling at a speed v meters per second experiences a resistance force of kV square newtons. The constant power of the van's engine is 62.5 kilowatts. Okay, so for the first part, we're told that the steady speed that the van could maintain while moving along a straight horizontal road is 50 meters per second. Show that k equals to 0.5 and find the acceleration of the van when its speed is 25 meters per second on the straight horizontal road. Okay, so to find this, okay, all right. The steadies. Okay, so we're gonna use P equals to FV to do this. Okay, so our power is 62.5 kilowatts, so 62.5 times 1,000. And then the force is, since it's moving at constant speed, like it has constant power, it should have constant speed. So the force it is exerting should be the same as the resultant force, so kV squared. And kV squared times V, that's kV cubed. Okay, so kV cubed is equals to 62,500. So this is equation number 1. Okay, now, okay, so the second part, we're told that the steady speed the van could maintain is 50 meters. All right. So, okay. Eh, oh, okay, so we just substitute V equals to 50 and then K 50 cubed. That equals to 62,500. And so just type it into a calculator. 62,500 divided by 50 cubed. You will get 0.5. So we have shown this result. Now we have to find the acceleration of the vehicle when the speed is 25 meters per second. Okay, so to do that, we have to find the force exerted by the van's engine when the speed is 25 meters per second. All right, so again, we're gonna use this formula. P equals to FV. So um, okay, so I believe we have to use the V cubed formula again. So this one would just be 0.5 times 25 cubed. So that is 7,812.5 watts. Okay. And now we can find the force using P over V. So that is 7812.5 divided by V, which is 25. So you would get 312.5 newtons. So this is the force that is exerted by the by the engine. Yeah. So now we're going to use Newton's second law, F equals ma. So F is the resultant force, not the force exerted by the vent. So you have to minus 312.5 from the resistive force, which is given in kV squared. So K is 0.5 and V squared is just 25 squared. And then that's equals to ma. So m is 2500. And then A is what we have to find out. So just take, oh, hmm, okay, hang on. Okay, um, 50 when its speed is 25. Oh, okay, so, all right, so I believe that, oh my, what's going on? Right. Okay, okay. So, um, all right, I believe that we're supposed to find the we're supposed to assume that the power of the van's engine is still this much, right? So yeah, so F equals to P over V. So P is 6 to 500 and then divided by V, which is 25. So 6 to 500 divided by 25, you get 2,500 newtons. So this is the force exerted by the van. Now we're going to find the resistive force, which is given by kV squared. So that's 0.5 times V squared, which is 25 squared. So this is equals to 312.5 newtons. Yeah, now we can use our Newton's second law, F equals to ma. So F is the resultant force. So 2,500 minus 312.5. That is equals to 2,500 A. So this gives us 2187.5 equals to 2,500 A. Hence, A is equals to 7/8 meters per second squared. So this would give us 0.875 meters per second squared. So this is our final answer for the first part. Let's head on to the next part. Okay, so for this part, we're told that the van begins to ascend a hill, inclined at an angle theta to the horizontal. And it also tells us that the van travels along a line of greatest slope of the hill. The speed of the van at the start of the hill is 20 meters per second, and its acceleration is 5 meters per second squared. Later, on the same hill, the speed of the van is 30 meters per second, and its acceleration is a meters per second squared. The power of the van's engine remains at 62.5 kilowatts, so it never changes throughout. And the resistance force remains at 0.5 V squared newtons. Okay, so for B, we're supposed to find the value of A and the value of theta. All right, so to do this question, let's first draw a diagram. So this is our hill with the angle theta. And at the very beginning, like here, we're told that it's traveling at 20 meters per second. And the acceleration is 5 meters per second squared. Okay, and then after that, at the later, the speed changes to 30 meters per second, and the acceleration is a meters per second squared. Yep. All right. So now we're gonna consider the forces acting at the start and at the end. So let's consider the start first. So first, let's find the force exerted by the van's engine at that point. So we can use P equals FV, make F the subject. So that's F equals to P over V. P is 62.5 kilowatts, so 62,500 divided by 20. So this one would be 3,125 newtons. And then the resistance force would be 0.5 V squared, which is 0.5 times 20 squared, which is 200 newtons. So resistance force is 200, driving force is 3,125, and we should also not forget the weight, which is 2,500 G. And as you can see, the weight also has a horizontal component of 2,500 G sine theta, acting in the direction of the resistive force. So now we'll use our F equals to MA. So F is the resultant force, so it will be 3,125 minus 200 minus 2,500 G sine theta. And that's equal to MA. So M is mass. So mass is 2,500 and acceleration is 5 A. So let's simplify this equation further. So that's 2,925 minus 25,000 sine theta. That's equal to 12,580. So this is our first equation. Now we're gonna consider later. I'm just gonna call it the end. So we're gonna use the same process, use our P equals FV and find F. So this is gonna be 62,500 divided by the speed then, which is 30. That's equals to 6250 over 3 newtons. Okay, now let's find our resistive force, 0.5 times 30 squared. So that is equal to 450 newtons. Now we'll use our F equals to MA. So F is 6,250 divided by 3 minus 450 minus the horizontal component of the weight, which is 25,000 sine theta. That is equal to 2,500 m times A. So A meters per second squared. So 6250 over 3 minus 450, you'll get 4,900 over 3 minus 25,000 sine theta equals to 2,500 A. So this is our equation 2. Okay, so now we have to solve these equations simultaneously. So as we can see, we actually have a common term, 25,000 sine theta, 25,000 sine theta, and both of them are minus sign. So we're going to eliminate that by subtracting both equations. So this would give us 29,250 minus 4,900 over 3 equals to 2,500 A. Wait, no. 12,500 A minus 2,500 A. So this is going to be 10,000 A equals to 2,925 minus 4,900 over 3, which is 3,875 over 3. So A would just be 387. Never mind, just type it into a calculator. You'll get 3,1 over 240 meters per second squared. So this is our value for A. Now let's find the corresponding value for sine theta. So we'll substitute it into second equation. So 4,903 minus 25,000 sine theta. That's equals to 2,500 times 3,1,240. So 25,000 sine theta. That is going to be 4,900 over 3 minus 2,500 times 31 over 240. You'll get 15,725 over 12. And then you'll get sine theta equals to 25,000 divided by 25,000, you get 629 over 12,000. And hence, to take the inverse sine, make sure your calculator is in degree mode. You shall get 3 degrees, or just 3 SF. So this is our final. Yep. Yeah, this is our final answer for this question for A and theta. Let's head on to the next question. Okay, so for this question, we're given a diagram. So the diagram shows the vertical cross-section ABC of a rough water slide. So that means along this surface, friction will be there. Section AB is a straight line of length 5 meters inclined at an angle theta to the horizontal. So you can see it's given in the diagram where sine theta equals to 0.8. The point B is 2.5 meters above the level of sea. So you can see it right here. A man of mass 80 kg, modeled as a particle, slides down the water slide, starting from rest at A. The coefficient of friction between the man and the straight section of the water slide is 0.1. So for the first part, we have to find the speed of the man at B. All right, so to do this, let's first identify the forces acting on the man. So obviously the weight would be acting. So the man is 80 kg, so weight is 80 g. All right, what else? So as I was saying before, there's going to be friction. So friction is acting in this direction. And this would be the normal contact force. We'll call it R. Okay, so to find R, you take the vertical component of the weight. So this is 80g cosine theta. So, okay. So we can equate R to 80g cosine theta. So let's make a right angle triangle here. So sine theta is 0.8. So 0.8, that is 4 over 5. So 4 is opposite, 5 is hypotenuse. So this one would be 3. So 80g, that's 800. And then cosine theta is 3 over 5. So 800 times 3 over 5, you'll get 480 newtons. Okay, now we can find our friction equals to mu r. So mu is 0.1 and then mu and r is 4,800 newtons. So this would just be equals to 48 newtons of friction. Oh, and then one more force to consider is the horizontal component of the weight, which is 80g sine theta. So this is the force that drives the man down, which acts directly opposite to the friction. Okay, so now we can find the acceleration by using Newton's second law, F equals to ma. So F is the horizontal resultant force, which is 80g sine theta minus F. F is 48 is equals to ma. So m is 80 and then a is just a. So 80a is equals to 80 times 10 times sine theta, which is 0.8, So 640 minus 48. So A is going to be 37 over 5 meters per second squared. And since the acceleration is constant from A to B, we can use our Suvat equations. Okay, so we know the distance from A to B. So we're going to use V squared equals to U squared plus 2AS, which by the way is given in your MF19. Yep. So this is the formula I'm talking about. So I want to find V squared, which is the final speed squared. So U squared is 0 since he started at rest. So it's going to be 2 times A, which is 2 times 37 over 5 times S, which is 5 meters. Yeah. So this is going to be 74. And then V would just be the square root of 74, which is going to give you 8.60 meters per second to 3SF. So this is our final answer for the first part. Let's head on to the next part. Okay, so and here we're given additional information that there is no change in the speed of the man when passing through B, and that his speed at C is 11 meters per second. Okay, so no change of speed means that the speed initially at B is squared 74, and the speed at C is 11 meters per second. So we basically have to find the work done against the resistance force as the man moves from B to C. Okay, so for this, since the surface from B to C is a curved line, we cannot use our forces, so we have to use an energy method for this. So let's find the initial energy. So initially, we have GPE and KE. Yeah. So, okay. Yeah, GPE and KE. So the GPE is going to be relative to C. Yeah, so 2.5 is the height. So MGH. M is 80. Then G is 10. And H is 2.5. So 800 times 2.5, you'll get 2000 joules. Now, KE, this would just be half mv squared. So m is 80, and then v squared is the initial speed at v squared, which is 74. And that is equals to 2960 joules. Okay, now we're gonna find the final energy at C. So at C, since the height is 0, there won't be any GP. So there's only going to be KE. So the KE is half mv squared, which is half times 80 times 11 squared. So 40 times 11 squared, you'll get 4,840. Okay, now we can find the work done against the resistive force, because according to the principle of conservation of motion, the total energy before should be equal to total energy after. And if there's a difference in the two energies before and after, it means that the energy has been lost as another form of energy, such as work done against the resistive force. This is also another version of your work energy principle. So let's add up the initial energy and then subtract it from the final amount of energy. So this would give you 120 joules. So this is our final answer for this final part as well as the entire question. Let's head on to the next question. Okay, so for this question, we're told that the particle x moves in a straight line. The displacement of x from O time t seconds after leaving O is s meters, where s is equals to this function in terms of t for this range of values of t from 0 to 4 inclusive. Okay, so for the first part, we have to find the velocity of x at t equals to 4. Okay, so to do that, we're going to have to find an expression for v in terms of t. So to do that, we're going to differentiate both sides with respect to t. So differentiating s would give you v, because the s dt is equals to v. So v would just be differentiating 0.3 t squared, 0.3 times 2t, and then differentiating 0.6t, you will just get 0.6. Hence, v is just equals to 0.6t plus 0.6. Hence, you should sub t equals to 4. You will get v equals to 0.6 times 4 plus 0.6. And this is equals to 3 meters per second. So this is our final answer for the first part. Let's head on to the second part. Okay, so for this second part, we're given additional information that for t more than 4, the acceleration of x at time t seconds after leaving O is a meters per second squared, where a is equals to this expression in terms of t. There is no change in the velocity of x at t equals to 4. Okay, so the velocity at t equals to 4 is still 3 meters per second. So, and the velocity of x at t equals to t is 14.2 meters per second. Okay, so for the first part, we're supposed to find the value of t. All right, so to do that, we're first going to have to find a function for v in terms of t for this t more than 4 from acceleration. So to do that, we're going to integrate both sides with respect to time. So integrating acceleration with respect to time, you get v, because acceleration is equals to dv dt. So integrating 0.3 times t to the power of 1/2, keep the 0.3 since it's a constant. Integrating half, you would plus 1 to the power, so that is 3 over 2 divided by the new power, 3 over 2 plus c. Okay. And then now v would just be equals to 0.3 times 2/3, which is 1 over 5, t to the power of 3 over 2 plus c. Okay, so we're told that there's no more change in velocity of x at t equals to 4. Okay, so we can substitute v equals to 3 and t equals to 4. So 1 over 5, 4 to the power of 3 over 2 plus c is equals to 3. Hence 3 is equals to 3 minus 1 over 5 times 4 to the power of 3 over 2. That's 3 minus 8 over 5, which is equals to 7 over 5. Yeah, so hence v equals to 1 over 5 t to the power of 3 over 2 plus 7 over 5. Okay, now we have to find the value of t. So we're going to substitute v equals to 14.2 and t equals to big T. So, this is supposed to be big T plus 7 over 5 goes to 14.2. Okay, so we'll isolate 1 over 5 times t to the power of 3 over 2. That's equals to 14.2 minus 7 over 5, which is 64 over 5. And you'll get t to the power of 3 over 2, that is equal to 64. Okay. Now, squaring both sides, you'll get t cubed equals to 64 squared. And then t, you will get by cube rooting 64 squared. So 64 squared, cube rooting, you would get 16. So this is our final answer for this first part. Let's head on to the next part. Okay, so now we have to find the total distance traveled by x between t equals to 0 and t equals to t. Okay, so to find the distance, we first have to find the expression for s in terms of t. So to do that, you're going to have to take your velocity function, which is right here, and integrate both sides with respect to t. So this is 1 over 5 times t to the power of 3 over 2 plus 7 over 5 dt. Yep. Okay. So this is s, and this is to integrate 1 over 5 times t to the power of 3 over 2. It's 1 over 5 times 3 over 2 plus 1. You'll get t to the power of 5 over 2 divided by 5 over 2 plus the integral of 7 over 5. That is just 7 over 5 t plus c. So s would just be 1 over 5 times 2 over 5. So s is equals to 2 over 25 times t to the power 5 over 2 plus 7 over 5 t plus c. Okay. Now we're going to substitute the initial conditions for this expression. Take note that this is only valid for t more than 4. So our initial conditions would be when t equals to 4. So what's the distance? Do we know when t equals to 4? Oh, all right. So s is 0.34. Yeah, so we're using this initial expression, the 0.4 squared plus 0.6 times 4. That is equals to 36 over 5. Okay, so 2 over 25 times 4 to the power of 5 over 2 plus 7 over 5 times 4 plus c equals to 36 over 5. And c would be equal to 36 over 5 minus 2 over 25 times 4 to the power of 5 over 2 plus 7 over 5 times 4. That's equals to 204 over 25, so you minus that. Okay, so you will get minus 24 over 25. So hence, we're going to write it in full for t more than 4. S is equals to 2 over 25 t to the power of 5 over 2 plus 7 over 5t minus 24 over 25. And then we're also going to write the other distance formula for t from 0 to 4. So that's equals to s equals to 0.3 t squared plus 0.6 t. Yeah, so this is our first answer. Okay, now we're going to do it. Okay, so do we have any? Okay, I don't think we do. Yep. Okay, so to do this, we're going to find, any so at t equals to 0. This is going to be O. And then we are going to have to find any inflection points in here. So you just substitute your t values. So 0, you'll obviously get 0. Then 1, you will get 0.9. And then 2, you will get 2.4. 3, you would get 4.5. And 4, you will get 7.2. Yeah, so this is until t equals to 4. Okay. Yeah. So the displacement is always positive. Yeah. So now we're going to find for the remaining values from t equals to 4 to t equals to t, which is 16. So now you have to use the other formula. You can use the trial and error. So, yep. Oh, sorry. T times 0, 5 to power 5 over 2 plus 7 over 5 times 5 minus 24 over 25. You'll get 10 point something something. Like I said, take note when it becomes negative. Okay, so it's still increasing. Yep, still increasing. So now 19 point something. Now I'm substituting 8. Yep, it's 24.7. Then 9. 31.08. And then 10. 38.3. And then 11. 46.5. Then 12. Doing this all on a calculator, by the way. 55.7. Okay, 13. 65.98. 14. 77. Okay. 15. Most likely going to be positive, but still. 89. And 16. It's going to be 130 times 136. Yeah, so as you can see, there was no turning points. So we can just directly substitute t equals 16 into the first formula that we wrote. So S equals to 2 over 25 times 16 to the power of 5 over 2 plus 7 over 5 times 16 minus 24 over 25. I got the answer while I was looking for any turning points. It is 103.36 meters. So this is our final answer for this final part, as well as the entire question. And we have come to the end of this paper. So I hope you found this video helpful. And if you did, please make sure to like and subscribe for more future past paper solving videos and tutorials of A-level maths and further maths. If you have any questions or doubts or future video ideas, feel free to leave them down in the comments below, and I'll see you again next time. Okay, thank you.